Before we jump to DLL hijacking and DLL proxying, let's first discuss how dynamic libraries are loaded into a process. So when a new process is started, System Loader loads a main module of an application as well as anti-DL library into the address space. Then it checks if there are any additional libraries needed by the program, and if so, they will get loaded as well. Okay, so that's basically how it works. Now you might wonder how Loader knows where to look for these DLLs, right? So in Windows, there is a defined DLL search order, and when a specific library is needed, System will look through all the places, one by one, until it finds, the right module and load it into a requesting process. So for desktop apps, the order is following. First, look if the module is already in the address space of the process. Then check known DLLs by reviewing list of values in registry key. Then check the application folder. Then check system folders like Windows System 32 for 64-bit processes and Windows Syswell 64 for 32-bit apps. Then Windows System and Windows folders. And finally, check current directory and all the folders from a path environment variable. So that's the search flow. So in other words, when an application starts, it will check its application folder for the needed modules, but usually they won't be found there, and they are located in system folder instead, like Windows System 32. If you have a write capability into application folder, so you can write files there, you can also hijack the DLL search flow, and your DLL will get loaded into the process before the legitimate module, okay? Sometimes applications might try to load a library which is not present on disk, and in these cases, you can also hijack the search order flow if you have a write privilege in any of those folders. That's how some of the privilege escalation attacks work, though those which are based on DLL hijacking. When you hijack an existing DLL and your module does not provide the needed functionality, this might break the application, which is something you would probably want to avoid from OPSEC's perspective, right? So what you might do instead is to create a proxy module, okay? So when the application calls for a specific function your module does not implement, it can forward the call to a legitimate DLL to serve the requested function. That way, you can still get the hijack working without breaking the application, okay? So let's go to our course VM to see how it can be done in practice.